Hi everyone, this is Ms. Dietrich. We're looking at a question that actually comes from the 2014 New York State Grade 6 exam. And this did trouble a lot of students, so I want to talk about it. It says, which expression is modeled by the diagram below? And they give us this number line and some two boxes here, what we might think of as a tape diagram, and we're supposed to analyze this and pick out which one of these expressions fits the picture. The first thing I'm going to recommend you do is let's take a look at what we might call the starting bar, and let's match up that on the number line. Because it does say 3 1/4, and if you hold it up on the number line, you can confirm that it is indeed equal to 3 1/4. All right, so now the question is, how are we breaking that up? Well, let's say we're deciding that 3 1/4 is the starting amount, and therefore that's got to be the dividend. We're going to try choice A. What I recommend is actually doing the algorithm, and then you're going to compare what you get with the picture just to confirm that that's the right answer. If we go through the algorithm, step 1 is to turn this into an improper fraction. 3 1/4 would be equal to 13/4. And then you would go ahead and do the keep, change, flip thing. So we would keep the 13/4, change the division to multiplication, change the divisor to its reciprocal, and then we would go ahead and go through the math. Let me move this little box out of the way so we can get the work. We can cross reduce here. The GCF of these two numbers is 4, so we're going to go ahead and divide by that. Here we get a 1, here we get a 1. The common factor, the greatest common factor between these two is 1, so we're just going to go right across. 13 times 1 is 13. 1 times 3 is 3. And then we're going to do 13 divided by 3 to get it back into a mixed number. This is going to go in 4 times. 3 times 4 is 12. Subtract, and we get the 1 left over. We'll make a fraction bar here. The remainder will become the numerator, and our divisor will become the denominator. So our answer here, when we went through the algorithm, we got 4 1/3 for choice A. And now we're going to check to see if the picture matches that. All right, so let's look at the picture. They're showing 4, so let's make sure we have 4 of these chunks. There's 1 chunk. There's 2 chunks. There's 3 chunks. And there's 4 chunks. So the 4 is consistent, so let's put a little smiley face above the 4. That's okay. Now let's check for the 1/3. Now the thing that people are troubled by is they're looking at this and they're saying, well, wait a second, that doesn't match this. And they're not really able to explain why. Let's take a look at another model that I have down here. Now what I've done here is I've just taken this and I put 3 of them together to show you that if I have 3 of these together, that's equal to one of these 3/4 chunks. So here's what you have to ask yourself. Let me pull this, or let me actually make it a different color so you can see it stand out. I'm going to trace this again, but I'm going to trace it this time in blue. That's one of the 3/4 chunks. And I'm going to move it down here. And then I'm also going to trace in a different color, how about red? I'm going to trace one of these 1/4 chunks. And I'm going to move it right in the blue box itself. Now if we study this model down here, I'll move that out of the way so you don't get confused. How many of these chunks, red chunks we'll call them, do we need to make up a blue chunk? And isn't it 3? We need 1, 2, 3 of these. So that's why we would be calling this red chunk thirds. That also explains why if we have one of these chunks that we'll call a red chunk, even though it's labeled here in the diagram as a 4th, it's really 1/3 of this blue box, confirming that choice A is indeed the correct answer.